Above shows the distances from Tom's house and from Patty's house to the school on Carver Road. Okay, so Patty's going that way and Tom's going that way.
Mhm.
Okay. Tom rides his bike from his house to school along Carver Road at an average rate of T miles per hour. Patty rides a bus from her house to school along Carver Road at an average rate of P miles per hour. What is T in terms of P? Okay. Um, Now the key here is that it takes them the same amount of time to arrive at school. So this is a distance equals rate times time problem.
Mhm.
Okay. So the in the case of like you got to do this for each person though. So there's Tom. Tom, his distance is 3. His rate is t. Now this is where it gets awkward because that's also t. So let's uh, let's say that t, big T. Let's say this t is really I don't know, big T. Is that okay or is that weird?
That's fine.
Okay. Now Patty, her distance is 9, and her rate is p, and since it takes the same amount of time, t. Big T, I guess, big T. Okay.
Cool.
So now the only variable that you can set these equal to is for big T. So you have to solve each one big T. Okay, so big T in this first equation is T equals 3 over T because you're just dividing both sides by T. And in the second equation, big T equals 9 over P.
Okay.
So now you can set these equal. 3 over T equals 9 over P. I mentioned this to you when we did some of the problems that I've created that you can change things horizontally or vertically.
Okay.
So like that 3 goes into that 9 3 times. Then you cross multiply here. So you have P times 1 equals 3 times T. So P equals 3T, but the question wants it in terms of P. So that means you have to solve for T. So T is equal to P over 3.
Can I see the answer choices again?
Yeah, and that is letter A.
Wait, didn't you get T? Did you get 1/3 P?
Yeah, P
Oh,
over 3
P
is
over
one
3.
third. Yeah.
I see. Okay.
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 Now there's a bunch of these D equals RT problems, and I've got I'd love to do a project where I give all the possible ones that exist. I just don't have them. So unfortunately, the only thing that I can do here is change some of the numbers and the letters here, but uh, I don't know if that would help. But I think we should at least try that. So let me change some of the numbers here and letters and see if you can do this on your own. So we're going to change this to 4 and 6. And this is going to be P and this is going to be T this time. So I want you to try this on your own. I want you to set it up as D equals RT, and you're doing it for both Tom and Patty.
All right. T.
I'm just putting a few steps down in case you want to check your work for this.
Okay. I'm almost there. So then you set those equal.
Because it says the same amount of time. There's a bunch of these problems here where it's like, and if it's the same distance, or if it's the same rate, and or if one's upstream and one's downstream, and there's a few different variations, but yeah, you set them equal because of that. Right. And when it says t in terms of p, that means to solve for that letter.
So solve for t, okay. So then we get t equals 3 over 4p. Right?
So I get 2t equals 3p. So t equals 3 over 2p, or 3 halves p.
Yes. Okay.
All right, let's do a related problem to this. Is that okay? Spend a little more time on this. Mm-hmm. Okay, so here's A, here's B, and here's C, and we know that A travels at I don't know, 10 miles per hour, and B travels at R miles per hour. If the distance is the same, what is the total time, or what is the time, I guess we can ask for. So these are all in the category of distance equals rate times time. Okay, so A is going this way and B is going this way. So you have to do it for each person or each thing. So the distance here, which we don't know, we'll call it D. The rate of A is 10, and its time is T1.
Okay.
Okay, and then for B, the distance is rate times time. Its rate is R, and its time, we'll just call it T2 because we don't know what it is. What do we know that is equal according to this problem?
These.
The distance is the same.
Mm-hmm.
So that means that the D's are equal. So you can set these equal to each other. You can say 10 T1 equals RT2.
Okay.
And maybe the question says, you know, what is R? So you could solve for R by dividing by T2. So R equals 10 T1 over T2.
Okay. So if it says what is R in terms of
T1 and T2 in this case, yeah.
So it would be you solve for R in that case.
Yeah.
Okay.
You have to be comfortable with this notation. The dental admissions test asks things like, you know, if you're traveling the first part of your trip at 50 miles per hour and the second part at 60 miles per hour, what is the average of your two parts of your trip? And you have to, it's not just the average of the numbers, you have to make a few more calculations. So this thing does come back, especially if you want to keep you know, taking more math. But let's move to question 14. Question 14 here. So this is a calculator question. Do you remember? I mean, no,
but it's the math. It's no calc. It's in the.
No, we're in the calculator zone.
Okay.
You could have. It says the graphs have how many points. So you could graph this. but graphing is slow. Like I would never tell you to do that.
Uh-huh.
Uh, but it is a path to always getting the answer.
Right.
So that you got to weigh that here.
But then
Um,
you might have to like change your window and stuff.
right. You might have to change your window, or what if you graph it wrong, or there's so many things you could do wrong. Um, there's probably a better way, but if you graph these correctly, you might be able to tell right away whether there's one solution or two. So do you have any idea what this first graph looks like?
Parabola, right?
Yep, something like that. Those 3 points happen at -1, 1, and one, -1 down there. How about this one? X plus y equals 4.
Straight line.
It is a straight line. Because of the way it's written, you actually, if x is 0, y is 4. If y is 0, x is 4. Like I'm looking at this thing, and I get a pretty good idea that it hits the graph 2 times. Okay. Are you comfortable doing that?
How do you know where, like, okay, so like I get on the parabola that it's down 1, but how do you get the points of like -1 and 1?
Inspection, I say, oh, what makes that 0? It must be 1. 1 squared minus 1 is that. Well, this one I just wanted to talk through because there's a lot of like possibilities for this that like you could graph this one. As long as your window is reasonable, you would see that there are 2 solutions. I think it's worthwhile for us to find the solutions. And to do that, you always use substitution, because that is the only way to solve these linear and nonlinear problems. So like, for example, we can solve I don't know, we can solve one of them for y. Like the second equation. In the second equation, y equals 4 minus x, and then you take that into the first equation. So you get 4 minus x equals x squared minus 1, and then you solve for that.
Okay.
Okay, now, no. Let's try another one here. Let's say I tell you that x squared plus y squared equals 4, and x equals y squared minus 1. This one's much harder because you can't really graph this one. And maybe you don't know what the graph of this one is.
Yeah.
But maybe you do, maybe you don't. I don't know. Do you have any idea what this is?
I don't know.
Okay, well, it's a circle.
Okay.
Okay, and it's got a radius of 2. Okay. So the radius of 2 here means it looks something like this. Okay. Any idea what this is?
An upside down parabola? I don't know.
If it were y equal x squared minus 1, what would it be?
A parabola.
Okay, and it would look something like this. Would you kind of agree with that?
Yeah.
All this does is it rotates at 90 degrees to the right. Everything flips. So it's a sideways parabola. Yeah, so it actually looks like this.
So, upside down would just be a negative.
Yeah. So how many places do these intersect?
2.
Right. So there's ways to do this where you don't have to graph, or they can give you questions where you really, even though you have a calculator, doesn't help you. So I guess my point is we might want to spend a little time like reviewing on what things look like. There are like 10 parent functions. So obviously there's y equals a constant.
Sorry, doesn't it depend on like the other one, like how far to the left you're going, because it could intersect like 4 points potentially, right?
It actually could, yeah. Circle and a parabola could intersect in 4 points. Yep.
Okay.
Which is good that you're seeing that. And then you got y equals x. That's a line. Y equals x squared. Y equals x cubed. And then we got like y equals square root of x, y equals x to the 1/3 power, y equals absolute value of x. That's probably all that you need to know for now.
Mm-hmm.
And then I think it's totally reasonable to give it to you as x as a function of y, which is kind of like what I just did. It's like x equals y squared. That's a sideways parabola.
Okay.
Kind of thing. I mean, that's me, but you know, this is
So anything in that case would be just flip sideways.
yeah. You
Like
can
if you did like square root of
x
x.
equals square root y.
Yeah.
Yeah, that's the top part.
Okay.
So I mean, these are less common, but you got to be comfortable with all of these. So like let's do one. Let's do one that's probably more realistic. Y equals absolute value of x minus 3. 2 equals x plus y. How many points of intersection do these have? And you can graph if you want. You can solve, but you've got to give me an answer here in like 60 seconds. Not literally, but that's the point here is, can you do it that fast?
Well, absolute value is like a v, right?
Right.
And then I'm not using my calculator, but
so do you know, like, yeah, it's a v, but what is this?
So
What
it'd be
does
like
that do?
2.
This causes it to go down 3.
Yeah.
So boom, boom. So if you can draw that, you're in good shape. Now, what is this x plus y equal to?
It's just a straight line.
Agreed. But where does it hit there and there? So now,
It's only in a 6-1.
how do you know that this doesn't hit with that?
Because they're parallel.
Okay. So I agree. Now there's a way to make it so that these intersect, but way out here. So you have to be careful that you actually know what's going on in that region. So let's move on to a new question here. Oh my gosh, this one has a lot of words. So I have questions like this. And we've done some like this. Let me see if I can figure out what the heck it's asking for. So I just give me a moment here to the mean distance from Mercury. Okay. All right. I can't even get all of this into a snip, but I will. This is incredible. So I do know that the questions we've looked at are intended to like prepare you for this, so it's not so overwhelming. One of the techniques is to immediately go to the thing that it's asking for.
Right.
All right. Now, it says the mean distance of Mars from the sun is k times the mean distance of Mercury from the sun. So this is all that matters right here. So the mean distance of Mars from the sun. So Mars is k times Mercury.
Okay.
Okay. Now, all of this is not relevant. All of this is not relevant. Okay. That's why you have to start here. Because if you're looking for Mars and Mercury, not important, important, important.
Okay. But
Because
does the sun matter or something?
nope.
Oh.
Nope. So Mars is 227.9. I'm just grabbing that from the table here. Equals K times 57.9. Okay, so go ahead and solve this for K. You got a calculator, grab that. You'll get the answer here. And then I've got some problems we can do like this that I think it's a better question, but I mean, obviously they don't take my questions for this, but let me get those.
So just dividing 227 by 57.
Yep.
3.9.
Yep, and that ends up being letter D. So let me get, hopefully I guessed right that this is the correct question. Nope, it's not that one. Maybe it's 5. Yes. Okay. This is in the same space. It's incredible how similar these are. But I made mine up and didn't take from here. I didn't take from here, but it's very similar. So let's look at this question and see if you can detect the information that is useful and relevant here. So go ahead and just read it to yourself, and then I'll jump in here after you've had a look at it.
Okay.
Have you been able to read through it?
Yeah.
Okay. There's a key word in here. The vibrations are directly related. That is y equals kx. Okay, so in this case, Croatia is related to Romania.
Does it matter which way you do it? Like,
Yes, it has to tell you. Directly related, it says one is directly related to the other.
Oh, okay.
So the order matters here.
Okay.
So it tells you that in Croatia it's 0.24, and that in Romania it was 0.72.
Right. What about the 0.65?
Say that again?
What about the 0.65?
Well, that's relevant, but it's not what we're asking about. Let's just say we asked to find the value of k. I know this doesn't ask you to find that, but what is the value of k here? You can use a calculator if you'd like.
Oh, find that. Okay.
Yeah.
0.24 divided by 0.72. 0.3333.
Yeah, k equals 1/3. Okay. Now, what is the question afterwards? It says, what frequency can Javier expect to be found on the same day in Romania? So it's saying, okay, same thing now. Croatia equals 1/3 times Romania. Okay. What are they in Croatia? It's 0.65.
Oh, when you're trying to find what it is in Romania?
That's right.
So in this case, you would divide by 0.3.
I would prefer hearing a multiply by 3 because this is actually not a calculator question. So it's and this is doable by hand. It ends up being 1.95. Okay, so let me give you one with, all I'm going to do now is change the numbers.
Wait, so if you so for 0.24 divided by 0.72, you just have to do that division.
Yeah, that's divided by. And this was no calculus. This one was, so that's why it's 1/3. You're supposed to be able to recognize that, but I'm okay if you use a calculator. It's not really what I'm trying to emphasize right now. Okay, so I'm going to do, actually, I'm going to do it without the multiple choice. I found with you that that's a really better way for you to kind of get some value out of this. So again, it's kind of the same. It's the same setup. It's not a different question. It's the same setup, just without the numbers. Give yourself about 60 seconds and see if you can work through that.
I got 0.056. Seems kind of small though.
That's not correct here. I'm gonna just jump in here. So Malaysia is directly related to the vibrations in the United Kingdom. Okay, so K times, we'll just use U for that. So they were 0.23. And then when he measured them again, and they measured them in the United Kingdom, and that same day it was 1.15.
Mm-hmm.
So what is K in this case? What does K equal? What does this become?
0.2.
0.2. Yes, 1/5. Yes. Okay, so now they're giving you the value of Malaysia. Malaysia is 0.28 equals 0.2 times U.
Yeah, I did that, and then I multiplied 0.28 by 0.2.
Okay, and what did you get?
Oh, wait, why in the last one did you multiply and not divide?
Well, because I wrote it as a fraction. So
Oh,
you have
that's
to,
why I messed up.
yeah.
I did that.
If you do this, then you multiply by 5.
Okay, so it should be 1.4 then.
Yeah, 1.4. Okay, let's try one more of those, again, without the answers, and then we'll do the related question to this. This one has a lot of like deception in it because of the countries are changing and the seismologist, and it's the third country and different, maybe you're like, wait, I didn't think Ethiopia had, anything going on there, but that's not the point here. It's all distraction.
So, okay. 0.73.
Give me that one more time.
0.73.
Yes, great. Okay. So now we're going to do the other fork, and for me, or for you, this one actually is it's pretty similar. It's just going backwards, meaning that instead of giving you one side of the equation, I give you the other. It reads really similarly. So just see if we can get through one of these, and then we'll
Oh, so it's just asking for the first country instead of the second one. Okay. Equals. Five. Yeah, 6. 0.3. So B.
Yes. Okay. Great. So let's see. The so question 16 refers to the same set of information we did for the other one. I don't think that it's worth us going through that at the moment.
Okay.
We'll move on to 17 here. This one again has a lot of words, and most students just they get tired. I mean, they they're like tired here. So
Yeah.
let me grab the answers. But I want what I want you to is focus on the question. What is
Okay.
and if you start there, do the words even matter? Like to me,
No.
to me, I say, okay, well, it says, what is the best approximation of the slope?
Well, I guess just the equation matters then.
Probably, yeah. But I mean, there's something else going on here. It says, based on the graph, which defines the best approximation of the slope of the line of the models between temperature and the specific heat device. So, like, I'm seeing something that goes up and to the right. So that's gone and that's gone
Right. Okay.
because they're negative. Okay, so now I'm down to 2. Now it's like, well, I don't know. Could go either way on that kind of. So, um, what would you do to find the slope?
Well, you could just rise over run.
Right, and you could pick if you pick places far enough apart. That might help here. I'm not sure. But its slope is y2 minus y1 over x2 minus x1.
Right. So it's okay. So the y2 is it 1.9 or 2 that you chose 2, I think.
That is 2.
So 2 minus 1.4 over negative 10 plus negative 100. Or plus
Right. Now here's 2 things to look at. What's the same and what's the different about these? This one is less than 1. This one's bigger than 1. Why would I? Well, a fraction generally you care whether it's bigger than 1 or less than 1. And for me, this is clearly less than 1 because you got a much smaller number on top. So I don't even have to use the calculator. I'm going to go with C on this.
Wait, how? Oh, never mind.
So
Okay.
this illustrates another question where if you go to the thing that it's asking for, you might say, oh, well, that equation there, but that equation is the wrong slope. So all of this is irrelevant for this question. Now I know maybe 18 uses it, but you've got to get to the point where you just go down to here and figure, well, what do I actually need? And none of that is important.
And process of elimination helps too.
And do you think you can do that? I guess is a good question.
Yeah, I think so.
Yeah, why not?
I mean, it like went from a 25% chance to a 50% chance.
Yes. Okay, now the next question is a little bit more involved, and I think that's an important skill here to know is that it looks like one piece of this is like pretty straightforward, like, oh, just it's kind of it's not a combination question. This one is. It says down here at the bottom, a piece of ice is a density of, based on the graph, which the following is the closest to the specific heat of this piece of ice. Now, when you look at this, okay, what do you see here? Do you see 920.4 on this graph?
No.
No, but there's an equation where the density is used up here. So if you put this number into this equation, what is x?
Temperature.
Temperature. So if you get temperature, can you get out specific heat? Like
Yeah.
if it's that, then you get that value, right? So the path here is D gives you x, and then use the graph to get specific heat.
So just plug in the 920 and
for D, and you got to solve for x.
Okay. 8.08 x plus 18. So then you subtract the 19. So it's well, I guess it's closest to 1.9.
So what did you get for your temperature for X?
-30.
Yeah, so 1.9-ish. Yeah, and
Like
that's one of the
1.8
answers.
something. Okay.
Yeah.
So you just round up in that case.
There's the answers are far enough apart that you don't have to worry about this there. So this is a combination question. You have to use the answers from one, and not the other. Okay. Did we do? Yeah. Okay. So we're going to switch to like more algebra types questions. The last ones we've done have been, very intensive on, story problems and a lot of words.
Yeah, pretty bad on the algebra ones.
These should be your strength, really. I mean,
I know.
well, you can do this. You can do this. If anyone's capable, you are. I mean, you work hard, you study hard, you're doing everything you can to do well here. Okay. When something asks for the value of 2x, what you have to realize is whatever the value of x is, you're then going to double it.
Right.
Okay. So that's the direct method. Direct method means you solve this for x, and then you're done. The indirect method is you solve for 2x. And if you're not sure what I mean, what's your first step here to solving this?
No.
You might add 2x to both sides and then add 1 to both sides.
Okay.
So you get 4x equals 6. Well, if you divide by 2, are you back to 2x?
Yep.
Yep. Then you're done.
I see. So then if you would have divided by...
If you would have divided by 4, which is what most students do, you get a fraction. You get, what is it? It's 3 halves. And then you could either choose the wrong one, or you could do a lot of things. And then you got to double it. You could double it wrong. I mean, there's so many things you could do wrong here. But the point of these problems is again, like you can save time by solving for the thing that they want you to solve for.
Right.
And if you just do it once on the test, you'll save time. So let's say it's 3x minus 4 equals 12 minus 3x. Okay. What is 3x? So give this one a try, please.
Okay. 4, 16. X equals 8.
So if we add this, we get 6x equals 16. Cut it in half, and you get 8. That's right. Okay, yeah, so you can do that.
That is fast.
You can do it. It just saves you time if you can do that. All right. That one we might not have time for. Okay, this one we can talk about. Let me just check one more here. They're going back into being sort of. Oh, here's a good one. This is because it's related to what we've been doing. Okay. All right. So this question, after I snip it in here, again, it's asking for what is the value of x minus 2. So you could find x, but you don't need to find x, because if you do, you have to subtract 2. So like the answer is probably 1, 2, or one of those, because if you get this, and or I'm sorry, if you get -1, you forget to subtract 2, or minus, so on. But they want x minus 2, so you should try to somehow solve for that. When we were dealing with factoring problems, do you recall using substitution?
Yeah.
Okay, so if you do that here, this becomes u squared plus 5u equals -6.
Yeah, I remember this. Okay.
And how do you solve something like this?
You oh, and then you factor that.
And you factor that.
Right. Okay. Equals -6. So then squared. Oh, okay. So the only answer is -3 then, because
Yeah, because the other one's not there. Okay. So for example, let's just say, let's do another one here. Let's say it was x plus 1 squared minus 4x plus 1 equals 5. And I want you to solve for x plus 1.
squared minus 4 plus 1. What, it'd be 5 and -1.
So did you get u squared minus 4u minus 5 equals 0?
Yeah.
Factor it, u minus 5, u plus 1 equals 0. So your get u is either 5 or it's -1. Now
Yeah.
this is a little wrinkle here. I'll throw this in here. Let's say instead of this, I wanted x plus 2. Well, x plus 2 is really x plus 1 plus 1. So you would take both of these answers and
Add 1.
add 1 to them, yeah.
So then how would you, if you didn't have multiple choice, how would you know which one's right?
They actually would accept either. So you could use both, because it would, in this problem it said which of the it wouldn't say which of the following, but it would say what is a possible value of x minus or x plus 1 or x minus
Okay.
1, and you would be able to easily do that.
But on the actual, like, okay, so like for this one we did, they would never put both -2 and -3 as answer choices, right?
No, if you ever get two answers, they've looked over this enough that would never happen. So you've done something wrong. It's not a case like where your math instructor just made it the night before and he's sleep deprived. It's you have made the mistake. So go back and figure out what's
right.
wrong.
Okay.
All right, so that closes out our lesson for today. So thanks again for letting me schedule with you a little later. I'll send out the notes and the screen recording out shortly, and let me know when you're ready to schedule again.
Okay, thank you.
You're welcome. Bye now.